Hey everyone, Mr. Armitage here. Second problem on the Unit 4 practice test number 2, 2B. Just a quick working through it. So this one is solve the polynomial by first factoring by grouping. Okay, so factoring by grouping, what we are doing is we are looking at, well, groups of our polynomial here and factoring out a common factor from just those two terms within here. Okay, so in the front, in these two terms here, 24x cubed plus 20x squared, we know immediately that we can take out at least an x squared because we have x squared here and x to the third contains an x squared because x squared times x will be x to the third. And now we can figure out that I believe we can take out a 4 as well, because 24 can be divided by 4 and 20 can be divided by 4 without any remainders. So let's look at that. 4x squared times something. Well, we have to get from 4x squared to 24x to the third. Well, to get from 4 to 24, we multiply by 6. And to get from x squared to x to the third, we already said we multiply by x. Now to get from 4 to 20, we multiply by 5, and it's a positive 5. And x squared to x squared, don't need to multiply by anything, it's just 1. So now we see here we have 6x plus 5. And so we need to get this, the negative 24x minus 20, to look like 6x plus 5. Now this tells me that first, we need to make this positive, right? This is plus 5, but this is minus 20. So we are going to factor out a negative number. And what negative number are we going to factor out? Well, look, we have 24 and 20 here. Oh, look, we have 24 and 20 here as well. So we're just going to factor out a negative 4. So there's our negative 4, or minus 4. And this now is going to be multiplied by, well, negative 4 to get to negative 24 here will need to be multiplied by 6. And we don't have an x, so we'll have to multiply by that as well. And to get from negative 4 to negative 20, we'll multiply by a positive 5, or plus 5. Now, what we have here are two terms of our polynomial. We've basically factored our polynomial into two separate terms, and they have a common factor between them. Okay? They have the 6x plus 5. So we can factor that out, and what we are left with is whatever 6x plus 5 was multiplied by, which in this case is 4x squared minus 4. Okay, now this is the factored form, so we're not done. This is just the first step in being done. To solve it, we have to set this equal to 0, because that's what solving polynomials means. And notice we have two things here being multiplied together. Now, it's possible for this, the 6x plus 5, to equal 0, in which case it doesn't matter what this 4x squared minus 4 is. That's going to be multiplied by 0, so that will equal 0 overall. Or it's possible for the 4x squared minus 4 to be 0, in which case it doesn't matter what 6x plus 5 is, because whatever that will be multiplied by 0, and we'll still get 0. So let's go ahead and do that. We'll find both values, all the values of x that make this true. So 6x plus 5 equals 0. Simple two-step equation for solving. We have 6x equals negative 5, divide by 6, and we end up with x equals negative 5 over 6. Okay, that is one of our solutions. We have a couple others. Next one, we'll get 4x squared minus 4 equals 0. Okay, we go about this the same way. Add 4 to both sides. It's essentially a two-step equation. We just end up with one little bit extra at the end. So add 4, that 4 cancels out. We get 4x squared. Divide by 4 both sides. Now we end up with x squared equals 1. Okay. Now at this point, we need to get rid of this square here. So we are going to take the square root of both sides. However, when we do that, what we're doing is telling us what number times itself will give us positive 1. Right? What number can we plug in for x that when we multiply it by itself will give us positive 1? And we know that that is positive 1 because 1 times 1 is 1, but also negative 1 because negative 1 times negative 1 equals positive 1. So there we have 2 solutions. Which works out, we have 3 solutions total, negative 5 over 6, positive 1, and negative 1. And so that's good. And if we look back at the original equation, okay, the degree was 3, which means we should have at most 3 solutions, which we do.